Make your own sinusoidal output inverter for a homemade generator. As we know, 220 volts is standard. A step-down transformer can not only reduce voltage but also increase it. To achieve this, we simply need to connect it in reverse and to the secondary winding, supplying a low variable voltage. Let's illustrate this. When connected inversely, one transformer reduces the voltage. Connecting the lamps, as seen, illuminates them. One might wonder about the purpose of these converters when our neighbors provide 220 volts, albeit with significant output losses. I'll demonstrate how this transformer can simulate a variable input voltage. Using a powerful PN transistor KT805DM and a 5.6 kΩ resistor, we assemble a multivibrator to simulate AC input voltage. Now, I must stress, I do not encourage experiments with electricity, as they are dangerous. Proceed at your own risk. The channel's purpose is to assemble and test devices, not delve into the principles of operation, as most beginners are interested solely in the device itself. Let's begin. I took a transformer with a midpoint of 14 volts, along with an NPN transistor KT805 and a 5.6 kΩ resistor. The resistance of the resistor is chosen based on the secondary voltage of the transformer windings, and also depending on the desired input voltage. We can use a 12-volt battery to power our device. When connected to the laboratory power supply, the device operates successfully, though the light isn't at full brightness, consuming 800 mA. Adjusting the resistance allows us to control the input voltage, thus adjusting the lamp's brightness according to our needs. For the experiment's clarity, the converter is connected to a switch, demonstrating its logical operation. Connecting a 30-watt lamp, it illuminates but lacks the intensity expected. The converter's power isn't adequate for full brightness. Even when the room light is turned off, the consumption remains the same. Adjusting the resistance further allows us to fine-tune the voltage input as needed. Connecting a lithium-ion battery of the 18650 type, as we see, everything operates, but the brightness isn't satisfactory. So, what's the expectation from assembling these components? Well, one good option is to generate any sinusoidal voltage. However, familiar devices we typically plug into the grid won't function with this converter, except for LED or low-power incandescent lamps, often referred to as economy lamps. I strongly advise against attempting to measure the output voltage of this converter with a multimeter, as the frequency of this voltage is beyond its capability, potentially damaging your equipment. Now, let's discuss another converter, not based on a transformer. 9-volt transformer with a midpoint and a different powerful PM transistor, the Lohan 1349, along with a 330 ohm resistor. We check its functionality. As we observe, everything operates successfully. The incandescent lamp and LED lamps glow without generating excess heat. However, as mentioned, it's crucial to verify battery compatibility. All details regarding the converter will be provided at the end of the video and in the description. You can utilize any transformer with a midpoint, along with any powerful NPN transistor and a suitable resistor. However, it's crucial to emphasize that this converter isn't intended for household devices or anything that plugs into a socket, as its output voltage cannot be measured with a multimeter. It's suitable only for LED lamps and low-power fluorescent lamps. To those who haven't subscribed yet, please do so. Also, remember to consider the price index. Ultimately, whether to utilize this device depends on your needs. In my personal experience, it proved immensely helpful when my battery-powered devices failed during a week-long absence, and this converter provided illumination using a car battery for approximately 5 days.
And finally, we have a gift for you that is tricks to reduce your electricity bill by at least 75%. And the way to complete energy independence, get rid of the monopoly of big energy. You will never have to pay for electricity. Method, amplify electricity to make output power greater than input power. See link in description. Thanks for watching.